All right, question 35. We have equation Q equal to 1/2 mv squared. The dynamic pressure Q generated by fluid moving with velocity v can be found using the formula above, where n is the constant density of the fluid. An aeronautical engineer used the formula to find the dynamic pressure of a fluid moving with velocity v and the same fluid moving with velocity 1.5 v. What is the ratio of the dynamic pressure of the faster fluid to the dynamic pressure of the slower fluid? Okay, so we're comparing two fluid. The first one has a velocity v, and the second one has a velocity of 1.5 times v. Okay, so we don't know what v is, right? But we know the second fluid is 1.5 times as big. Okay, what we could do is we could just plug in using the formula, plug it into equation and solve just using the variable v. Or we can also use some test number, actually pick some number for v, right? And then we can also pick some number for n and solve it out and compare the q value and see the difference, right? So either way should work. If we're just using v here, okay, so see the original formula is q equal to 1/2 mv squared. Okay, if v is just the regular v, then q should just equal to 1/2 mv squared. Right, q should equal to that 1/2 mv squared. But now if v is 1.5 times as what we had before, the new q value will be 1/2 times n times 1.5 v. Right now v is 1.5 times as big, so it'll be 1.5 v, and this whole thing will be squared. Okay, so the trick here is you have to put it in parentheses and the whole thing is squared. So that means when we square this, not only will we square the v, but also we have to distribute the square to the 1.5. Okay, so the number 1.5 will be squared as well. Okay, so that should give us 1/2 times n times 1.5 squared is, you can type in the calculator, is 2.25 v squared. Okay, 1.5 squared, this is 2.25. So you see, compared to the original q, right, you see everything's the same. Right, we still have the 1/2, the n, and the v squared. Right, the only difference is this whole thing is multiplied to 2.25. So we can rewrite this as 1/2 nv squared times another 2.25. So you see, this 1/2 nv squared is what we had originally, right? But the new one is, right, is times 2.25. So how much bigger it is, right? What's the ratio of the faster fluid compared to the slower fluid? Because if the faster one's a new one, right? So that's 2.25 times compared to the slower one. Okay, so the ratio should be just this number right here, the 2.25. Okay, everything else will be the same as the 2.25 times. So that should be our ratio. Okay, it'll be 2.25. All right, so that will be our final answer for this question. So the trick is the velocity is 1.5 times as fast, but then since v is squared, so we had to square that ratio. So 1.5 squared, we get 2.25.